In this video, I will be going to perform similarity search demonstration. So let me show you some list of documents which I have already written. So here you see this is first document, and in the content it has resume details like there is a data engineer with 5 years of experience and the skill levels like Python, SQL, building ETL pipelines, etc. And in the metadata you have name, email ID, phone number, etc. So you see this kind of details you have in the form of document, and I have already told you document have page content and metadata. So this kind of information, let's say human resource department have. I have right now 5 documents which I have created, and if you notice like document number 4, so this document number 4 is similar to document number 1. Here also Python, SQL and ETL operations that person can do. So Alice and Diana. Diana also has Python SQL experience, and ETL she can also do, also have the experience in BigQuery and Snowflake. So document 1 and document 4 are similar. Similarly, this guy, document 3, who is Charlie, he has experience in AWS, Kubernetes, and similarly, this guy of document 5 also has the experience in the similar thing. And this guy has different experience of Java, Spring, etc. So these are the documents which has metadata information and page content. And you see, I have created the list of documents. I included each document variable in list. So that's fine. I have created the list of document because I have already told you when you do the add documents, you require list of documents. And this time I will create the database in the hard disk. So for that, what I will do, I will use this persist directory attribute, and the name of the directory is Chroma folder. This time the data or the embeddings will be stored in the hard disk. Then you see vector db.add document. What it will do, it will first convert all the documents into embeddings and also save it in the Chroma DB. After that, using the get function, I will be going to see the documents and metadata, and I will be going to print the result. So these things you have already seen. So let me run this particular command. So here, if you notice, 5 IDs are created for each document. A unique ID is created. This is the unique ID of document 1. This is the unique ID of document 2, and so on. Also, embeddings are generated. It is showing none because I am not displaying it here. And in the documents, these are the documents which are there, and here is the metadata information of all the 5 documents. So that's good, it is working fine. And if you notice here, a folder is also created, Chroma DB, and inside this folder all the embeddings are stored in this particular folder. So now I am ready with my database. Now what I can do, I can perform the search operation. So I will copy the whole code and you see paste it in a new file. So here I paste it again, and what I will do here, I don't need these documents now because these documents are already present inside the database. So I delete this. So I delete all these things here. So embedding I used this time is text embedding 3 small, and last time I mentioned the dimension also, which was 512, but this time I didn't mention the dimension property. So this time it will be going to create 1536 dimensions embedding, which will be better than 512. So I expect my results to be better. If you want more better results, instead of small, you can use large, but it will be costlier than the smaller. Okay, so this model I am using, fine, and I have to use this command also. Then I don't need to do add document. Why? Because documents are already there in my database, so I delete this command also. I don't need this, and I don't need the result at the moment, so I remove the result option as well. So that's fine. Now what I have to do, I need to use the vector DB object, and there is a function here which is known as similarity search function. And under similarity search function, I need to ask the query and the value of k. So first I will be going to write the query. So my query is equal to that HR is looking for a data engineer with Python and ETL experience. So this is a requirement of the company. So I put the requirement of the company in the query, and I am interested in those guys having the experience in Python and ETL, and I will be going to set the value k equal to 2. It means for this query, I want two matching results. So I am looking for a data engineer with Python and ETL pipeline experience. Now what this similarity search will do, it will do two things. Number one, it will convert this query into embedding, and number two, it will trigger ChromaDB to perform similarity searched based on this embedding, and the result will be returned. So this result I will be going to capture. So I will equate it with the result, and let me put it in different line for better clarity. So I captured the result. Now you see I will be going to print the result and run this particular command. So here I have got two document ID. This is document ID 1, this is document ID 2. So I got two guys, one is Dinah, and Dinah is having a Python experience, also ETL experience. In the same way, this guy also have ETL experience and Python experience. So both are fine. So that's a very good result it has provided. Instead of this query, I am passing different query that I am hiring cloud engineer with AWS and Kubernetes skills. So if I run this, so let's see what kind of output I get. So here you see this is a cloud and DevOps engineer with AWS Kubernetes skills, and there is another one. He is cloud engineer with these skills. So that's fine. It has given me very good results. And also there is one more function in this, which is underscore by score. So similarity search with score. It will also give me scores. So let me run this. Here if you see, this is 0.59 score for this, and there is 0.65. The less score means it is more closer to your query. So if you have a bigger score, it means it is less closer to your matching result. If you get the less score, it means the result is more closer to your asked question. So this is what score represents. Now I will print the result in a better way. So what I will do, first I will remove this with score option. Just I will use similarity search, and I will be going to remove this, and I will write for R in result, and after that I will be going to print the name. This name information is already there in the metadata, so I will write R dot metadata, and in bracket I will be going to write the name. Also if I want email ID, so here I will write email, and in the metadata I also have the email information, so I will write R dot metadata, and in bracket I will be going to write the email. Also I will be going to print the page content, so I will write r dot page underscore content, so it will give me the description which I have. So that's fine. So because the two results are matched, so it will be going to display the name of the first person and the email ID of the first person and the details of it. Then it will give the name of the second person and the email ID and the details or the page content of it. So if I run this now, if I go to another file, so you see these are the page content and this is the metadata information which I have. So here I got the name and the email ID, and this is the page content, and this is another name and these are the page content. If I go to another file, here if you notice, this is the page content and this is the name, this is the email ID. So the information is displayed in a better way by using this